We have press communication, outreach, diversity, and last but not least, an important society business meeting. If you get bored at any one of those menu items, let me remind you of our 17 posters. I'm now calling on Professor Carsten Dominique of the University of Amsterdam to introduce the first dish of the menu, the 2 NWO Awards. Carsten, take it away.
Yeah, thank you very much, Peter. I'm really honored to award the 2 NBO Science Awards that go to astronomers this year. So the NBO Domain Science Awards, those are 5 special scientific prizes that are being handed out every year for inspirational teamwork. That's a Team Science Award. For science communication for a wider audience, that's a Communication Award. Awards to foster diversity, the Diversity Initiative Award and the Athena Award, and an award for the societal impact of scientific results, the Stairway to Impact Award. And so this is the first year where these prizes are awarded, and it turns out that 2 of those prizes go to astronomers. And the NBO had the idea that the handing out of those prizes will happen at the disciplinary conferences as much as possible. So that's why we can hand out these prizes here. The first award I'm proud to present is the Communications Award. The Communication Initiative Award rewards initiatives of successful and inspiring science communication by scientists. Per year, at most 3 of those initiatives are being funded with an amount of 10,000 euros, and that prize money is intended for activities with relation to the original initiative. And this year's winner is the outreach team of the International Astronomical Union 100. That is one of the winners. That initiative brings together a global range of activities and projects to promote the importance of astronomy. Over 5,000 activities in 143 countries were reached, and they were executed, and they reached an estimated 100 million people. The jury at NBO was really impressed by this reach and by the inclusivity of the initiatives. IAU 100 has expressly set out to embrace diversity and to reach countries in which people have limited access to scientific knowledge. The initiative was launched by the team manager, Dr. Peter Russo, and team members, Dr. Jorge Rivero Gonzalez, Bethany Downer, Lina Canas, and last but not least, Marieke Baan. The NBO Communications Office has prepared a short recorded video with the prize winners, and I would like to ask Fritz to show this video now.
Yes, one sec.
From the city of Leiden, at the oldest university observatory in the world, the Leiden Observatory, I would like to thank NBO for this award. This is the recognition of hundreds of individuals that worked so hard in 2019. So on behalf of all of them, thank you so much. This award is actually quite important for us. So I really hope that communication becomes a part of the scientific enterprise. I think it's really important that we communicate the results of our research, and especially for a field like astronomy that sometimes it feels so far away from our daily lives, that we really implement communication in our work. So we want to, in a way, give something back. So with the money that we receive for this award, we're going to have a call for small projects where anyone that wants to implement a project in astronomy communication or astronomy education can apply. And then we're going to distribute some micro grants that are going to allow people to organize more events, hopefully already in 2021, but most of them will be in 2022. And for some reason, these days I run some research projects in public understanding of astronomy, but I'm also implementing a series of projects in astronomy communication. I'm going to be very involved with the NVA project about black holes research. It's going to start this year, that we're going to try to see how can we bring cutting-edge research to classrooms all around the Netherlands, but also around Europe. And we're going to really try to see how can we bring some of the enthusiasm and some of the sense of discoveries that we have in astronomy, in modern astronomy, that every day we discover new things about the universe, and how can we transfer that to the classrooms and to the teachers, and especially to the students.
Okay, thank you, Fritz. I think we should all give a round of applause for this first prize winners. Thank you. So the second award is the Diversity Initiative Award. The Diversity Initiative Award goes to the Altair project, which introduces primary school children to astronomy and to physics. The Diversity Initiative Award rewards initiatives that promote diversity in the field. Altair's instigator, Professor Sarah Markov, receives 50,000 euros to spend on the project. The jury was impressed by the way her project has brought attention to the hard sciences within a variety of communities. Children from different ethnic backgrounds are given lessons by researchers from the UVA, and their parents are also brought into a variety of activities at the university campus. The project reaches 140 children per year. The jury considers it noteworthy that Sarah Markov launched this initiative alongside her regular research work. And I can just say that I've witnessed this project from nearby, because it's happening in our institute. It's something that makes us really proud, and I think it's a very innovative way to reach out to the communities that actually lives very nearby and is normally completely separate of what's going on at the university. Also for this, we have a small video, and if you're wondering whose office this is, where there's a bottle of wine on the table in front of the keyboard, that's my office, which Shea hijacked in order to record this video. Fritz, can we please see this video?
The overarching theme is, what is Invading Scrapper? I don't know, Marika always has the magic touch, like mine always fall off. And we emphasize the fact that you don't have to be, somehow smart or have special skills. It's just about being curious. I'm trying to figure out if that's part of the bug, or like lint.
I think it's just lint. I think it's dust. It's just gotten a bit dusty.
Yeah. We're working with kids that are very, very not represented in Dutch academia. And this can only be because of lack of opportunity or lack of exposure. I believe very much it's both. I mean, I came from the kind of family that didn't have, academic science people in it at all. And I never would have become a scientist if I hadn't had a bit of this. I went to an elementary school that was an experiment that had some science activities, and it really just got me interested. Also in English, so. Funding is critical for these kinds of efforts. It takes a lot of materials we have to buy every year. It takes support. Science communication, I think, is still undervalued in the Netherlands. Yeah. It's immediate, right? Yeah. It's pretty cool. It's important to educate the public who are science skeptical, and the more that we have good science communicators and good science interested people, they're going to grow up into science interested adults, not necessarily scientists, but people who support science. So this helps support that kind of work. If we can start to create a pipeline of a more diverse Amsterdam population coming to University of Amsterdam, which is just a few blocks away, I think that will also be sustainable by word of mouth. That you start with a small group of kids, and then people start to see that this is a place that you can belong and feel comfortable, and that science is for everybody. And that's kind of the message that we're trying to get out.
Yeah, okay, Fritz, thank you very much also for showing this video. And I think now that we need a round of applause for Sarah and her team who's running this project. Yeah, thank you. I think what's also important to mention is I think it's really excellent that NBO has launched these prizes. I think that really puts efforts on a different kind of initiatives, which is really good. And in this context, I would like to remind you that the call for the next round of prizes is open actually right now. The deadline is 15th of June, so you are still able to nominate people or to apply prizes. Really depends on how it works on the details. Maybe Fritz, you can show the image with the website, just as an advertisement. Yeah, so the website is nbo.nl and then /domain-science-prizes. All the information for all those prizes is on their website. And as I said, the deadline is 15th of June. So if you can think of outstanding women scientists, of good initiatives, and for the various categories that they have here, then I would really encourage you to propose a candidate or to apply for one of those prizes. And that's all I wanted to say. Congratulations again to the winners. And I really hope that next year we might have more winners that we can present at a similar occasion. Back to you, Peter. Thank you.
Thank you, Karsten. Well, also on behalf of the board of the society, congratulations to the winners. And we're going to move on to another winner, Mark Oosterlo. Mark finished his master's project at the Kaptein Institute with Inga Kamp in the summer of 2020. He's now carrying out PhD research with Inga and Wim van Westrenen, the Free University. For his master thesis, he received the 2020 De Zeeuw van Dishoek Prize, dealing the research, with the plate tectonic effects on the atmospheres of exoplanets. I now invite Mark to give us a brief report about his master project. Mark, take it away.
Yes, thank you very much. First of all, I would like to thank you for giving me the opportunity to present my master research project at this conference. And I would also like to thank Emilie van Dishoek and Tim De Zeeuw for awarding their graduation prize to this work, which I finished last year. And what we have been doing for this project is we've indeed looked at the effects of plate tectonics on the evolution of the amount of CO2 in the atmospheres of Earth-like exoplanets. And well, in addition to Inga Kamp and Floris van der Tak, I also did this master project together with Dennis Heuning, who is an Earth scientist at the Free University. So, as probably everyone in this meeting knows, by now we have quite a number of confirmed exoplanets. And if you look at the diagram here on the right, you can see that some of these planets are quite similar in terms of the mean density and radius to Earth and Venus. And in addition, some of these exoplanets we've discovered so far may also just have the right temperature to sustain liquid water on the surfaces. And the question which is raised in the context of these planets is, are these planets actually habitable? And well, we know one planet which is definitely habitable, which is Earth. And one mechanism which has been very important for the stabilization of the surface temperature of Earth is the carbon cycle. And we think that this has allowed Earth to stabilize its surface temperature over geological timescales, which was favorable for the development of life on Earth. And essentially, this mechanism constitutes the recycling of CO2 between the atmosphere, ocean, mantle, and the mantle. And a question which, well, as an astronomer, you can then maybe, when you think of this, ask naturally is, could this maybe also affect the long-term habitability of Earth-like exoplanets? Well, when asking such a question, you immediately run into the problem that you have only very limited information on these exoplanets, and that the carbon cycle we understand best, the one on Earth, is heavily affected by plate tectonics, water cycle, and other factors which we only know to exist on Earth. Nevertheless, Earth's carbon cycle is the one we understand best. So let us, in this presentation, take Earth's carbon cycle as a starting point. And what's really key in the stabilizing effect of this carbon cycle is temperature-dependent silicate weathering, which is, in this figure, the reaction shown here on the right, left. And the idea is that this reaction can remove CO2 from the atmosphere and converts it into bicarbonate. However, this reaction increases with temperature, and CO2 is also a greenhouse gas. So in that way, you more or less have a negative feedback mechanism which stabilizes the surface temperature. And well, after this reaction has proceeded, the bicarbonate, after a number of physical and chemical steps, ends up on the seafloor as carbonate rocks, where it can subsequently be subducted in a mantle from where we can either degas back in the atmosphere or just remain in the mantle. However, subduction is a process which is associated with plate tectonics, and also degassing is actually associated with plate tectonics. But plate tectonics itself is really a surface manifestation of what is happening in Earth's mantle, namely mantle convection. And that in turn depends on the mantle temperature and its evolution. Altogether, carbon cycling is thus connected to the thermal state and evolution of the mantle. And that's where our project comes in, because what we specifically looked at is what is the influence of a planetary interior different than Earth on a carbon cycle of such a planet. And in order to answer this question, we have developed a semi-analytic computer model, which incorporates both the carbon cycle itself and connects it to mantle convection and its evolution. And we use that to make first-order estimates of the evolution of the atmospheric CO2 pressure. And again, we really take Earth as a starting point here and then extrapolate towards exoplanets. So let me briefly discuss this model a bit better. So the first part is a thermal evolution model, which we use to predict the evolution of the mantle temperature, which is essentially the average of the temperature you can see over here. This cartoon more or less summarizes the thermal evolution model. So we have a convective mantle layer on top of a isothermal core. And well, we can then calculate the evolution of the mantle temperature by considering at each moment in time the processes which heat and cool the mantle. And well, in our case, our mantle, we assume that it can be cooled through this upper thermal boundary layer, and is also heated from below by the cooling of the core and heated internally by the decay of long-lived isotopes of uranium and thorium. And well, you can then express these heat fluxes through these upper thermal boundary layers in terms of a conductive heat flux. But the mantle as a whole is convecting. So what we did is to incorporate these effects of mantle convection on these heat fluxes is we parameterize this thickness in terms of the Rayleigh number, which is a measure for the vigorousness of mantle convection. And then what you get in the end is the evolution of the mantle temperature over time. The other part is the carbon cycle model. And what we here do is we take a total carbon budget, which we divide over various reservoirs, one for the atmosphere, ocean reservoir, one for the plate, one for the mantle. And then we have all kinds of processes which can exchange carbon from one reservoir to the other, such that you can find the evolution of the contents of these reservoirs by setting their derivatives equal to all the processes which add or remove to such a reservoir. And it gives you this set of differential equations, which you can then integrate over time, and then you find your time evolution. So, but where does the connection between the two models come in? It comes via the plate speeds, because I won't discuss all the fluxes in detail, but the idea is that many of these fluxes depend on the plate speed. However, we can express the plate speed in terms of Ra, which is the mantle Rayleigh number, and D, which is the mantle thickness. So it depends on interior properties. And this Rayleigh number is a measure for how vigorously the mantle is convecting. And it depends on temperature gradients, the mantle thickness cubed, and also on the mantle viscosity, which has an exponential dependence on the mantle temperature. So in the end, the plate speed is really governed by the mantle temperature via the viscosity, via the Rayleigh number. So what kind of evolution of the plate speed do we then find? Well, what I do here is show you the time evolution on a logarithmic time scale for the plate speeds. And what you can see is that compared with a model which mostly assumes a constant plate speed over time, that we initially start off due to the hotter interior at a way higher value, and then gradually it declines over time up to, well, in the very long time scales. But what does this do to the amount of CO2 in the atmosphere? Because that's what, well, we can ever hope to possibly observe from exoplanets in the foreseeable future. Well, that is where these different colors also come in. Because if we now go to the amount of carbon in the atmosphere reservoir, you can see that these different colors denote different initial distributions of carbon over the various reservoirs. And well, what you can see if we compare a model with a model which has more constant plate speed over time is that in the longer term, we have a gradual decline of atmospheric CO2 due to the fact that our plate speed is decreasing, and that results in less degassing. And what you can also see is that, well, after a while, our reservoirs reach some sort of equilibrium where we forget about the initial distribution of carbon over the various reservoirs. And you can see that for our model, where the plate speed is much higher, that moment comes about 10 times as fast as for the model which has a constant plate speed over time. And, well, what is important to note is that actually we can use this, what we did in our project is we use this moment where we forget about our initial distribution to define a equilibrium timescale, which we have chosen as a timescale which we can use as a measure on how fast the carbon cycle on a given planet operates. And well, for this model, which represents Earth, we found this particular value of 160 mega years. And that allows us to compare for interiors different from Earth, which is what we are going to do now. So one parameter you can vary is the abundance of radioactive isotopes in the mantle. And that's the first result I would like to show you with regards to extraterrestrial interiors, so to say. And what is shown in this figure is the amount of CO2 in the atmosphere for different mantle abundances of thorium and uranium. And the idea is that if you have more isotopes, that you have a hotter mantle at any moment in time, which results in faster moving plates, and therefore you find a higher atmospheric CO2 pressure over time. So more isotopes means more CO2 in the atmosphere is the trend which our model points towards. And if we then look at this equilibrium timescale I was talking about in previous slides, you can see actually that, well, due to the hotter interiors, the plate moves faster. So this equilibrium timescale, in fact, is also shorter. But what I also would like to point out here is that compared to the model which is depleted in CO2 that we depleted in radioactive isotopes, what you can see is actually that we have about a spread of 20 mega years, which compared to the entire age of, for instance, planet as Earth is not very long. So radiogenic heating does not have much of an effect on the equilibrium timescale or how fast carbon is allowed to cycle throughout the interior, so to say. Okay, let's move to some other parameters which we looked at. One thing we looked at is at the core size of a planet, or the core mass fraction, so the fraction of a planet's core, the fraction of planet's mass which is inside its core. And well, the idea is that if I increase my core mass fraction, the metal becomes thinner, which can then cool faster, and then I get a cooler mantle, which results in a lower Rayleigh number, lower plate speeds, less degassing. So altogether, we find less CO2-rich atmospheres on planets with a large core. And we can do a similar analysis for planets with different mass. So here I vary the planet mass from about the size of Mars towards 2 Earth masses. And well, the trend you see here is that, well, again, the mantle thickness increases towards planets which are more massive. And that means that they cool less quickly. So they undergo more vigorous convection. So that increases the plate speeds, results in more degassing. So towards more massive planets, you find more CO2-rich atmospheres. Well, for these two cases, the core mass fraction and the planet mass, we can also look at these equilibrium timescales I was talking about to find about the timescale on which such a carbon cycle would typically operate on these planets. And then you get these results. So here I show you in blue the equilibrium timescale for different core mass fractions, which is here at the bottom. And here at the top, we have different planet mass, and that corresponds to the orange curve. And horizontal is vertical is the equilibrium timescale. And the idea is that in general, the plate speed is the factor that limits that equilibrium timescale. And that's towards planets with a colder mantle that the plate speed is lower, so the equilibrium timescale is longer. So it should be no surprise that we find the longest time scales towards small planets or planets which have a large core. And in particular towards planets which have a very large core, we find that above a core mass fraction of 0.7, 0.8, we really go into the giga-year regime with our equilibrium timescale. So that seems to be a very clear hint that towards planets which have a very large core mass fraction, that carbon cycling mediated by plate tectonics may actually not be a very efficient way in, transporting carbon around. And that's essentially what I wanted to share with you in this presentation. I put on my conclusion slides, and well, I leave it to the, I give the word back to Peter Bartel.
Thanks, Mark. If there are questions, folks, please put them on the chat or the Slack channel. I would like to ask Professor van Dishoek or Professor De Zeeuw if they would like to share a few words with us.
Happy to yield the floor to higher authorities.
Hello, Mark. Good to see you again. We've already had a very nice ceremony at Koninklijke Hollandse Maatschappij van Wetenschappen. That was in November. Unfortunately, also virtual. I wish that this could have been in person, but I'm very glad that you also got to tell your story to the astronomers, and it's a very interesting story. In fact, I'm actually curious, how many planets do you now actually expect to have sort of runaway CO2 concentrations and runaway greenhouse effects? And can you make any predictions as to what sort of the parameter space you would need to be in?
I think that that is a question which is more related to also, I think that, for instance, so I think you're here really pointing towards a dichotomy between Earth and Venus, I think.
Exactly.
Yeah. So I think that that is still a question which is not very well addressed, so to say. But yeah, indeed, so what we did with this model is really took Earth as a starting point. So then you don't necessarily get Venus out for certain conditions, so to say. And I think that to address such a question, it's also very important to look at the formation history of these planets, and also, for instance, how much carbon did these planets initially get, find out how different initial compositions of a planet can give rise to. And then I'm mostly pointing towards water budgets and carbon budgets, which I did not discuss in this presentation, and how that then affects planetary evolution.
Good. Well, congratulations again, and I'm very happy to see multidisciplinary work highlighted here. That's also the future of many aspects of our field of astronomy. And I also want to thank the jury again, which was certainly not Tim and myself, just to make that clear, for choosing such a wonderful winner. Congratulations again, Mark.
Thank you.
Also from me, Mark, very clear talk. Thank you.
Thanks very much, Professor De Zeeuw and Van Dishoek. I'd also like to congratulate you on behalf of the board of the Society, Mark. Thanks for your report of this very interesting research, and we wish you all the best in your PhD project.
Yes, thank you.
Now, it's a great pleasure to introduce Dr. Massimo Schiavelli at this conference. He is staff scientist at the Space Telescope Science Institute in Baltimore since 1995. He was involved with Hubble since then, but became the GWST project scientist in 2008. Since 2012, he is leading the GWST mission office. And I'm very delighted that he accepted my invitation to update the Dutch community on the revolutionary GWST. Massimo?
Thank you, Peter. I'm happy to be here. I sort of was for 10 years before I moved to the States, a honorary Dutch in a sense, because I would visit regularly. I hope that you can see my presentation. Okay.
Perfect.
So I'll jump into it quickly. So on this plot, you can see on the left the types of signs that have been approved for cycle 1 GWST on the general observer area, the GO. As you can see, there is a wide range of signs that has been approved. And as a consequence of that wide range, for some of my talk, I'll be speaking about science in areas that are far outside my field. We had some surprises. We had more proposals in the exoplanet and exoplanet formation area than expected, which is, I could say a pleasant surprise. Fewer proposals than we expected on stellar physics and stellar ties. But overall, it's a very interesting and balanced program. I spent a weekend reading 2/3 of the abstracts of approved proposals, and there is a lot of interesting science, including ways of using the telescope that were not really expected at this stage. So the community is already, we always know that once you have a great observatory, the community uses it in ways that were different from what was planned, but this is already starting in cycle 1. On the right side, you can see the fraction of time on cycle 1 split by proposal category. The GOs is the general observers, those that were just selected, and represent more than half the time. There is a slice to calibration, which is probably bigger than it will be in later years, because this is the first year of GWST. The GTO is guaranteed time observers. These are the folks that were involved with the science working group, helping design the instruments, set the requirements and so on, and they build, includes the people who built the instruments. And then there is DD, ERS, and DD. DD is the director's discretionary time. ERS is the early release science. So even after enabling the early release science, there is time left for the director to tackle with unexpected events. I should say that about a fifth of the total time on cycle 1 will be immediately public. So all ERS proposal data are immediately public, and a large chunk, about 2,000 hours worth of geoscience, is also immediately public. So there will be data for everyone once we start, once we enter operations. Wanted to show this slide quickly. We, of course, look at all kinds of statistics. For GWST, we use what we have been doing for Hubble for a couple of cycles, that is the so-called double anonymous. So the proposals are reviewed by panelists who don't know who the proposers are. Proposers are requested to anonymize their proposals. And this is the acceptance rate by gender. And as you can see, within statistical, a 1 sigma statistical error, it's an even distribution across the board, with, in fact, a little higher fraction of acceptance, again, within statistical error, but in a nice direction to see for female PIs of large programs. So we are reasonably happy about that. Is going. Particularly, there were concerns that COVID could have impacted some people more than others, and in fact, even in terms of seniority of the PIs, we have done well. There are a fair number of junior PIs, so the outcome is better than what one might have expected given the circumstances. So jumping in on the science, I'll start with the galaxy surveys. On the plot on the left shows existing established legacy surveys with Hubble in yellow squares, and on a depth versus area representation, and the cyan squares, did I say, so yellow triangles, the cyan squares are the GWST approved programs. This is a range, some of them like Jade's are GTOs, so the others are GOs. But as you can see, already in cycle 1, we'll get significant improvements on the depth and even area at a given depth over years of Hubble surveys. Jade's D will achieve significant depth over a much larger area than the XDF. Cosmos W on the opposite side will achieve interesting depth over 0.6 square degrees. So we have a whole range of surveys. We already in cycle 1, we have what people in the field call the wedding cake. where you cover a larger area in a shallower way, and you go deeper on smaller areas. So we already have these, and these surveys will serve probably as hunting grounds in the field for years to come. They will enable to provide reference imaging data for galaxy assembly studies, look at the sources responsible for ionization of hydrogen, and probe the area of first galaxies pushing beyond redshift 10. This is the equivalent for spectroscopy, where I've just looked at for various surveys the number of galaxies that they are going to capture. This is based on the proposals, so I had to use estimates from the proposals. But all galaxies above redshift 6 in yellow, and above redshift 7 in cyan. And I apologize because I didn't differentiate them for folks who can't see well these colors. Canucks and Fresco, the color bar is for redshift 7, and Sears and Uncover, the color bar is for redshift 6 or greater. So these surveys will provide line diagnostics for thousands of galaxies. Many of them are targeting the familiar optical rest frame lines at the redshift of these objects. They will enable the characterization of physical properties, including kinematics, metallicity, temperature of the ISM in these objects. And there are multiple spectroscopic surveys that will look at large samples of galaxies to redshift 7 and beyond. If we move to there are a lot of studies of individual galaxies. Some of them are famous objects that are at higher, among the redshift champions. For these objects, people will attempt to measure in detail the same physical properties I mentioned, notably metallicities. There are also a number of studies that take advantage of gravitational lensing, which is what I'm indicating with that frontier fields image of about 2744, to get an extra boost in terms of depth. So a lot of studies in the area of first galaxies and reionization characterize Lyman alpha absorption and all that. At lower redshift, a lot of favorite objects, the antennae, 1/18, and many others will be looked in great detail. The cross evolution of AGNs and galaxies, the evolution of the luminosity function, all topics that have been looked with Hubble and ground-based telescope will be revisited with James Webb. Similar for the intergalactic and circumgalactic medium, people will be looking at galactic fountains, will be looking at a large-scale structure, revisiting giant filaments discovered, for instance, on the ground with VLT Muse, and adding the GWST angle to that, which is an angle that allows you to do spectroscopy of faint object, look at the mid-infrared, and also, of course, imaging. Cosmology is also the target of a bunch of proposals. One of the issues that developed while GWST was in construction was the so-called tension, which is illustrated on the bottom right diagram, where CMB-based or very large scales-based measurements of H0 are in apparent disagreement with more local measurements from type 1a supernovae and other indicators. So there are a bunch of proposals that want to address that tension, trying to either confirm it or make it go away. Some of those are based on quasar cosmochronography, where you look at strongly lensed quasars. In a strongly lensed quasar, the 4 images have different lengths of their light path. So if you monitor the time delay between the multiple images and have a model of the lens, you can in principle derive the cosmological parameters from a single quasar. Of course, there are errors, both systematic and statistical, so you need more than one quasar lens, but there are programs that are targeting this type of science to mostly improve the lens models with GWST to reduce that type of error. There are programs that are trying to improve the calibration of cepheids or to improve the calibration of the tip of the red giant branch method in order to all these to try to address these tension issues. There are some programs that there is a program that is attempting to address the difference between warm and cold dark matter, also using strongly lensed quasars. The issue there is that if you have an amplification anomaly, this could be the result of additional lensing contribution. For instance, microlensing, a star passing along close to the line of sight of one of the images and alters the amplitude ratio compared to what it would be just on the basis of the global lens. However, if you look at the outer regions of the dust tori in the quasar, these things are too big to be microlensed by a star. And so you can tune it so that you can be sensitive to 10 to the 6 or 10 to the 7 solar masses halos. So if you look at a bunch of lenses and you look at the lensing anomalies and you see a statistically significant number of anomalies in the dust tori, this requires the mid-infrared instrument, which is the, because of time constraints, I didn't spend much time describing the instrument. Of course, the mid-infrared instrument is the product of a joint collaboration between the US side and a European consortium led by Gillian Wright. So this statistical study of the amplification anomalies for the tori would provide evidence that there is or there isn't a number of dark halos at that type of masses, 10 to the 6 and 10 to the 7. So in principle, it could lead to make a statement about the dark matter spectrum at those masses, which implies whether or not you have CDM or warm dark matter. The lower left picture shows Jupiter, and you might wonder, what does it have to do with cosmology? There is a very interesting proposal to study the extragalactic background light. The problem with the extragalactic background light is that the zodiacal background from our solar system is stronger than the EBL that you want to measure. So how do you do that? Ideally, you would want a spacecraft at 3AU where the zodiacal background is much lower, so you can focus on the extragalactic contribution. These folks have proposed to use the Galilean satellites of Jupiter while they are in occultation, while they are eclipsed by Jupiter, as occulters. So you look along the line of sight occulted by the Galilean satellite, and that gives you an integrated measure of all the Zodi up to that point. And there isn't much Zodi beyond Jupiter. So essentially you measure all that matters. And then if you keep staring at that line of sight as the Jupiter satellite moves away, you add to that measurement that is now known the contribution from the extragalactic background light, which you can derive by difference. So this is, I thought, a brilliant proposal, and it's certainly worth trying. And obviously the TAC agreed with that since they got time to do this experiment. There are a lot of proposals on AGNs, the nuclear regions, and the host galaxies and their interactions. A lot of the most famous objects were looked at. They are also will be looked at. There are a lot of proposals looking at outflows, feedback, and environment of AGNs. An interesting thing, I thought there are a couple of proposals having to do with the Milky Way, the galactic center. And one of them was a little bit surprising when I read that title, because they want to map the far ultraviolet background using James Webb. And I thought, well, I thought we were more of an infrared telescope. Well, it turns out that there is a neon 6 line at 7.6, I think, microns. So you can map a neon 6 emission through GWST in the infrared. And of course, it takes pretty energetic UV to produce neon 6, so that gives you a measure of the far UV background in the galactic center with GWST. And there is also another proposal that is trying to play a similar game as have been played with the black hole in M87 on the galactic center, involving also GWST. So there are a lot of interesting science and interesting ideas on that too. Moving closer to our galaxy, there are a lot of programs looking at protoplanetary disks. I should say in these, as in many other areas of science, a lot of programs are relying on the synergy between ALMA and JWST. So here, for instance, is an example of a program to do follow-up 5 to 28 micron spectroscopy of the disks in the ALMA D-sharp sample. There are programs to do coronagraphic studies and to search even for protoplanets in a number of these disks. I cannot see the time, but probably I'm going fast. So equivalently, there are a number of studies of debris disks to understand their dynamics and evolution, looking at young planets that are sculpting the disks, and look for warm molecular gas. And obviously, the mid-infrared instrument is particularly powerful for this kind of studies. A number of studies are looking at ices, and they are, understand the origin of water and organics in planetary systems, look at the absorption bands of ices, and there are programs also that will push the study of ices to higher redshift galaxies, studying ices in dusty galaxies. There are searches for complex organic molecules in some young stellar objects, deeply embedded. So there is a whole range of projects on the study of ices. And I remember perhaps Evine was one of the first people to talk about the potential for this science in the context of what was called at the time Next Generation Space Telescope. There are a bunch of programs to characterize exoplanets, of course. And as a reminder, there were really not many exoplanets known when we started NGST. In fact, the only exoplanets known were around pulsars at the time. So there will be a look at the diversity of exoplanets, which is what the figure is supposed to show. We are not going to observe all of them. I think the dots are all the exoplanets known, not all of those planned for GWST. There were several transiting of Jupiters, a planet in the so-called Neptune desert. The direct imaging and spectroscopy of cold gas giants, some Neptune super Earths, a couple of lava balls, very hot terrestrial planets, and a number of studies of planets around M dwarfs, which is perhaps the area where GWST can perform particularly well. One of the things we can do by focusing in the infrared is to look at molecules like water, carbon monoxide, methane, carbon dioxide, etc., that allows us to go deeper into the atmosphere of these exoplanets than if you were doing just probing at optical wavelengths. And it helps to do more detailed atmospheric studies on heights and composition of the clouds and hazes, the variations of the atmosphere, and so on. I should say that there are also a few full phase studies where you look at the exoplanet as it's transiting and as it is eclipsed by the star. So both the exoplanet in front and behind the star. As I mentioned, there will be a dozen planets smaller than Neptune that for which we'll study the atmosphere, including trying to understand whether stellar activity from active M stars enables an exoplanet to have an atmosphere, and the properties of atmospheres of those lava worlds that I mentioned earlier. And I'm getting close to the end.
Plenty of time, Massimo.
Yeah, but you know, I charge fast, and there will be time for questions. As you are aware, there's been claims of detection of an exoplanet. It was mentioned even earlier in the earlier talk around Proxima Centauri, and there is a program to use the MIRI coronagraph to look for direct detection of hot gas giant in the Alpha Centauri A. And I think the shaded area in the plot is the area that we would be sensitive to for this particular experiment. And there are, of course, cool gas giants around the whole range of other objects as well. So I wanted to spend a minute or two talking about the program. The cycle 1 observations that I've just described will nominally begin at launch plus 6 months, so at the end of commissioning. GWST has to deploy and travel to the L2 Lagrangian point, which is 1.5 million kilometers away from the Earth, and where it orbits on a pretty large orbit around that point. For the dynamicists in the room, L2 is a saddle point, so is a non-stable point. It's stable in one direction, unstable in the other. So we need to use fuel to maintain an orbit around L2 in order not to drift away, which is ultimately going to be the limiting factor for the mission. Commissioning is about 1 month of deployments, where we deploy the sun shield, of course, the solar panel, antennas, and then the mirror. Then there are 3 months of optics alignment, where the primary mirror and the secondary mirror are aligned. When you initially turn it on, you have the image you get is the image from 18 out of focus hexagonal telescopes that each producing an image. So you have to align them and then make those images coherent, so that you get the full width of max of a 6.5 meter telescope, not that of a 1.3. And this goes through multiple iterations and takes about 3 months. So real instruments are used for this alignment, but real instrument characterization starts in the last 2 months of the 6 months. The last 2 months are for instrument commissioning. So you can think of it as if we were not deployable, we would be a more normal mission with 2 months of commissioning, but because of all the deployments and alignment, it takes 6 months. So we won't be realistically doing any science until 6 months post-launch. The early release science program, which is about 500 hours, is designed to inform the community about what kind of data the telescope can actually take. And that's why they are immediately public. We are trying to do these observations in the first 5 months after the end of commissioning, so that people proposing for cycle 2 will have access to some on-orbit data that can help them write those proposals. The pleasant surprise from cycle 1 was that, as I mentioned earlier, that there are about 2,000 hours that people more or less volunteer for immediate release. And so even without any preferential scheduling, which we cannot really afford because scheduling a telescope is difficult. So you don't want holes in the program, and you don't want to reduce your observing efficiency, but it means that something maybe a quarter or a fifth of those data will be taken in the first 4 months. And so they will effectively double the amount of public data that will be available early and will be able to inform the cycle 2 geocall. The plan for the cycle 2 geocall is launch plus 11 months, which with our October 31 LRD would be September 2022, and the deadline is planned for L plus 13 months, which will be sort of November 2022. And our current plan is to engage in activities to highlight the on-orbit performance and early results sometime late August, September 2022. All these dates are a little, we don't know we know where we want to launch. We don't know the exact launch date. There is always a little uncertainty about launching. We don't know how long commissioning lasts. It's planned to last 6 months, but that again is a plan. But ideally, if we stick to this plan, sometime between late August and early September next year, we'll plan to have a little conference in the Institute where we'll present what we have learned about the telescope. We'll invite probably some of the folks that have obtained data and are willing to release them to inform the community about the telescope performance on orbit. So we are in the final stretch. If you go to Northrop Grumman, where the telescope is, it's a lot less nice to see than it was a couple of years ago, because now it's getting all wrapped up and getting ready to go into the launch configuration. And after the 6 months of on-orbit commissioning, we'll be start executing this extraordinarily ambitious science program that I've tried to describe to you. I'm sure not making full justice for the brilliant ideas that the proposers have put forward, and we expect major surprises in many areas of astronomy. Thank you.
Thank you very much, Massimo. Now there's about 20 minutes of time for questions. So can I just ask participants who like to ask questions to speak up and ask their questions to you? Anyone out there to ask something on this extraordinarily ambitious science program, which I agree it is?
Oh, Peter, we should speak up because I raised my hand and
yes, please speak up.
Now lowered. Okay, thank you, Massimo. This was really a very, very nice overview, and especially mentioning these highlights was very fascinating for me. For example, this highlight about the background determination by observing the occultation of Jupiter's satellites. That's something really out there. So since the TAC approved that, I was wondering whether you know more about, like, for example, whether there was a time allocated for some projects like very high risk, high gain, something like, for example, observing a couple of hours to see whether somebody can detect interstellar asteroids like Oumuamua arriving, and then giving us enough lead time to launch something to intercept, some projects like that.
Funny that you asked that, because I was kind of hoping that somebody would. There is indeed a target of opportunity program to observe with GWST the next Oumuamua. So the time has been granted, and it's a TO because we don't know if it will happen over the next year. We don't know where to look. So this is what we call targets of TOs, targets of opportunity. We have two kinds. We have the disruptive that need to be activated and done within 2 days, 48 hours from activation. And we have the non-disruptive that are not so time constrained. So you can take 2 weeks to actually do it once you know where to look. So I don't recall if the Oumuamua one is a disruptive or not. I don't remember the time delay that they requested, but we have such a program. And in fact, out of curiosity, I'm a GTO myself, and I like to think that it's nice if you have the time to try a long shot that maybe would never be approved by ATAC. So when we were supposed to launch in 2018, I looked if GWST was powerful enough to still see Oumuamua, the first one, and it was very marginal. It hadn't been detected by Spitzer. Of course, GWST as a larger collecting area, but it was very marginal. Launching in 2021, I think it's hopeless to see that one, but we are ready to look at the next one.
Okay, thanks. I was thinking more of not TOs, but somebody proposing to stare at a piece of sky just like that, at a favorable piece of sky. I mean, for example, the direction of motion of the solar system or something like that. But probably that was deemed too risky. Yeah,
I don't know. I watched the TAC. It was very interesting, but of course I was jumping from one panel to another, so I don't know. And probably even if I knew, I couldn't say if such program has been proposed. But I don't think there is anything in the accepted pool that is doing that.
Okay, thanks.
Other questions? Please speak up, people. So can you say something about the oversubscription in the various science areas, Massimo? Were they sort of distributed equally?
Yeah, it was roughly distributed equally. The overall oversubscription was maybe lower than what I would have expected in a normal year. Of course, with COVID, one needs to mitigate the expectations. The thing that I found really encouraging was that listening to the panels, many panels make comments along the lines that their proposals were all very good, very high level of proposals, and some even went on to say that none of the proposals that they looked at was too bad as not to be worth doing. So in many cases, it was, the cut has to happen because we only have a finite number of hours, but there would be valid science even if we had more hours available. So the proposal were very good, even though we had perhaps fewer than one could have expected.
I see a question by Leo Butcher.
I can also say hello. Thanks a lot for the very nice overview. I was just wondering about the lifetime of the mission. I heard it's 5 years and then another 5 years are kind of optional. Can you remind us what is limiting it and how long will it likely last?
So the requirement is 5 years because it's very hard to build something that guaranteed to last longer than 5 years, and it becomes very expensive. But as a reminder, I think the guaranteed life for the Wide-Field Planetary Camera 2 on Hubble was 3 years, and they had to remove it from the observatory to make it stop. So these things can last a long time. So the only expendable we have on board is fuel. We need fuel to maintain the orbit. As I said, it's an orbit around a non-stable point. It's also biased because we don't really want to fire our engines on the telescope side. We have always to fire on the other side of the sun shield. So that means that if we had to push toward the sun, we wouldn't be able to do that. So we stay a little bit on a deficit so that any push we need to do will be away from the sun. So this is a detail, but it essentially says that we need fuel to stay on that orbit. We also need fuel to unload the reaction wheels. Whenever you steer, you of course use the reaction wheels in order to change your pointing direction. But since we have a big sun shield, there is also torques from the sun on the sun shield that add up. So all these effects lead to what you might think of as a random walk in the space of angular momentum of the reaction wheels. So it tends to grow, even though in principle you could try to balance it, observe in one direction and then observe in the opposite to balance it. That would impact efficiency. So we'd rather not do that to maximize observing efficiency. So occasionally we need to use fuel and occasionally means probably, I don't know, 3 weeks, every 3 weeks to spin down the reaction wheels. We carry fuel that would enable 10 years with the 3 sigma bed orbit injection by the Ariane. So, since we hopefully won't have a 3 sigma bed injection, we hope that we'll have fuel for significantly longer than 10 years, but that's the requirement.
More questions?
Could I ask something about the stellar physics program? I've seen you've discussed very many topics, but not much about the stellar astrophysics part of the program.
Yeah, I mean, as I showed here, there are programs on stellar physics and stellar types. Totally open. I haven't, when I said I read 2/3 of the abstracts, that means that there is a third of abstracts that I haven't read. So overall, in the numbers of proposal in that area was less than we would have expected. And the folks have been speculating why. I don't know. I can't provide more details on that.
And the information is all on the web, right?
Yeah. All the abstracts of all the proposals that I have talked about are all available on the web.
Excellent. Thank you.
Other questions? Well, if not, then thank you very, very much, Massimo. This is really great. And it's good to know that there will be early release data already in 2022 for us to look at. Next time when I'm in Baltimore, I will bring you a little present. Thanks on behalf of the Dutch community for this excellent talk. Bye-bye.
Thank you. Thank you very much for inviting me.
So next item on the menu is the director of the Isaac Newton Group in La Palma, Mark Balsais. We are, however, 10 minutes too early. Is Mark around?
Yes. Hi, Peter.
Hi, Mark.
I'm here. Just tell me when you want me to start.
Well, please go ahead.
Good. Let me see if I can share my screen. That should be it. I think you're seeing
yes.
WST Dome.
Yes, we have it.
In the spectrograph, and you can hear me well.
Yes.
Excellent.
We have plenty of time.
Good. No, I will not use it. I've prepared a quick talk. I just first of all thank the organizers, Peter and Renier, for making a slot to be able to present, to give an update on the Isaac Newton Group to the National Astronomy Conference. Maintaining the contact with the community it requires a dedication. and especially more now with COVID. So I didn't want to let this pass without talking to you. So let me see. I suppose it's been several years, so there's going to be people in the community, in the Dutch community, need a refresher of where is the Isaac Newton group. It's in the Canary Islands and the island of La Palma, and it's sitting. Our telescopes are sitting at the edge of the caldera, the Taburiente collapsed crater on the island at 2,400 meters. We're not alone there. It's a tremendous concentration of telescopes. It's 16 professional telescopes actively carrying out observations on all sorts of apertures, technologies, wavelengths, including the 10-meter Grand Tecan, the GTC telescope, the MAGIC gamma ray telescopes, the Cherenkov telescopes, plus some that are newer ones that are they haven't made it into the photo yet. So it's a big place for astronomy. And essentially what I would like to pass on to you, to the Dutch communities, is first that of course that we have WEAVE. You have heard a lot about WEAVE the past years, I'm sure. But WEAVE on the horizon of 2022 to 2027, it's planning 8 massive surveys, plus access through open time. And so it's a tremendous science opportunity for the ING communities. And I will highlight that we are preparing a WEAVE postdoc program here at the ING. Beyond the WHC and WEAVE, I will talk about INT because we have strong progress towards securing a HARPS 3 instrument. It's another HARPS instrument, a planet finder spectrograph, that should be arriving in 2023. And that telescope, that instrument, which is built by an external consortium, will offer 50% of its time in open time to the ING community. So it's another opportunity for all of the extrasolar planet science. And finally, we'll talk about the student program, another opportunity for the young ones. It's a program that we are planning to increase in the coming years. And I'll discuss the Dutch participation. So WEAVE is a new facility at the WHT. We're planning 8 massive surveys. More than 400 scientists in Europe are organized in various groups preparing the surveys, and are actually very well prepared already for these surveys. And I have to emphasize, of course, that the whole WEAVE enterprise has a tremendous Dutch contribution. So it has come to be what it is, thanks in big part to the Dutch contribution. And I'll mention the role of a project scientist that Scott Traeger has carried out extremely well, and then the fact that the spectrograph was built at Dwingelo by the NOVA group. So it's an important contribution. So WEAVE, I suppose, it's clear to many of you that it comes out of the idea that we need to link our individual facilities to the big platforms that are out there, including Gaia, including LOFAR, and Aperitif. And these are the 8 surveys. I will not go onto the science details because that's not the purpose of this overview talk. But you'll see it covers Milky Way archaeology, which we're talking both accurate radial velocities and chemistry for several million Gaia stars, mapping the thin disk, the thick disk, and the halo. So tremendous contribution to the knowledge of the Milky Way and to the knowledge of galaxy formation. Together with that, a stellar, circumstellar, and ISN physics that is derived from some of these data, targeting star clusters and the ISM around stars. So another important, a lot of physics in there too. A third, white dwarfs. White dwarfs are actually observed. We're going to be observed as calibrators for the spectroscopy, flux calibrators. And it was clear that there was a lot of science to be obtained if those calibrators were observed in the right way. And this is what we're doing. Then there is several lines of galaxy cluster studies. There's a big project on stellar populations at redshift 0.4, reaching up to 0.5. There's WIF LOFAR, which we're doing optical spectroscopy for LOFAR sources. Of course, this is one project with a lot of Dutch contribution. And WIF Aperitif, where we're doing optical spectroscopy again, integral field unit spectroscopy for aperitif galaxies. And number 8 is QSOs with all the cosmology interest. So a tremendous, very broad science program. And we're really excited to have prepared that science program and to know that we have such tremendous science teams ready to exploit the instrument. Now, what is the timeline? The timeline is that we now expect the surveys to start in 2022, following a science verification program. This will last for initially 5 years, using 70% of the telescope time. The other 30% is offered in open time, and also for other instruments, including technology development. So if your science is there, get in touch with teams if you are still not there. Just join us. Recognize the postdoctoral opportunities that are important because they imply joining large, strong collaborations, and that's always good for your own career. Speaking of postdocs, at the ING, we are preparing a postdoctoral program that would link to postdoc positions in the WIF teams. So we would kind of add 1 year to postdoctoral appointments in the groups. What is the advantage? The advantage is that we would be gaining, these postdocs would be gaining a very deep knowledge of WIF data, the WIF instrument, WIF science data survey gathering. They would establish strong ties between the survey teams and the observatory. That always helps to extract, to optimize the science that you obtain from the data. We believe there is a strong support for this program, and the photo below is one of the meetings where we introduced this program. You see that there was some level of enthusiasm for having a scheme of that sort, and we're now working on funding schemes that need to adapt to kind of the postdoctoral funding for the UK, for the Netherlands, and for Spain, which of course are different in each country. Couple of pictures on the instrument, just to give you a feel for the sheer size of what we have put together. Look on the left, on the top left. This is the corrector, the prime focus corrector. On the bottom right is one of the lenses in that corrector. It's 1.1 meters in diameter. This is tremendous optics. This has been in the telescope, mounted on the telescope for nearly a year, and I won't resist the temptation of showing how first light occurred. What is first light? The first light is pointing at the sky one night, and this picture at the top left. This is how first light is done in COVID times. So there is a team at the WST control room with their masks. And then it's the project manager, the instrument scientist, and the director from home over Zoom. And we point to a star, and we take the full width half max of that star. And you look at the bottom right image that within half an hour of taking the first data, we were focusing at 0.6 arc seconds, full width half max, on a lens that delivers 2 degrees diameter field of view. And this is a measure of the quality of the corrector that has been confirmed throughout testing over about 3 months of testing of the optical quality. So the corrector is really performing extremely well. And of course, I wanted to show you how we welcomed the arrival of the truck that had left Dwingelo a few, perhaps a couple of weeks before, and was now arriving at the Roculus Muchachos Observatory carrying the NOVA spectrograph. And a couple hours later, the spectrograph was being hoisted up into the clean room in the Nesmith platform of the WHT. And here it is. That afternoon, the first afternoon, it had all the VPHs already mounted. Here, proud Dutch engineer showing how things are done when they're done right. So the spectrograph is there. Now we're waiting to receive the detectors that are going to be mounted next month in mid-June. Going to be mounted onto the spectrograph to start testing and shining light through it. And finally, the final positioner made by Oxford is making progress on La Palma. It's really unfinished, and we are helping to finish it. It should be ready sometime this summer. So enough of WEAF. Let me move to the INT. Very briefly, the INT is the 2.5 meter telescope that has been exploited for many years with the wide field camera and the IDS, the intermediate dispersion spectrographs, and for which we have a plan to change its shape completely. And this is to bring HARPS, a HARPS type instrument. We have made plans, we have made contracts, and a consortium led by Didier Queloz from Cambridge, who was a Fleming Nobel Prize winner for the work for the paper that proved the discovery of the first Earth-sized planet around Earth and solar-type stars. Well, they've created this consortium to build a third HARPS-type instrument and install it on the INT. This will come also with a modernization of the INT. It will become a robotic telescope. So what is the deal for the community? The deal is that the consortium provides an instrument and makes the telescope robotic with modern electronics and modern controls, and uses 50% of the time. The other 50%, the other entire 50% of the time is for the ING communities. So here's a range of opportunities for the whole of the extra galactic, for the extrasolar planet community. So think that with WAVE on one side and with extrasolar planet community with the INT, we're covering a big range of options of the main research lines for the future, for the immediate future in astronomy. We don't just do research. We emphasize a lot the role of training that a facility needs to have. And the student program at the ING consists of inviting a student to come and spend 1 year with us, working as support astronomers of the INT, doing their own research too, and their own observing. So this program has been very successful in that has given people, the students, a lot of experience with telescope operation, with telescope observing, and with a lot of opportunity to interact with senior astronomers to come to observe. We take 6 students every year from the 3 partner countries and from other countries sometimes, but mostly from the partner countries. This is a very oversubscribed program with over 40 applications every year. And I want today to make this special mention the Dutch students. We want you. And why do I say that? Well, just because of the histogram here on the left. This is the nationalities, the universities, the nationality of the universities from where the students come. And the Dutch students are underrepresented very significantly. So we've been analyzing whether this is because of selection criteria, somehow it penalize Dutch students or what. And first sight, doesn't look like it. You know, if we look at the applications, how many applications do we receive? And you see, again, we have a deficit of Dutch applications. Whereas the success rate, which is how many do make it in, over how many have applied. Of course, the Dutch are still below, but there's not that much difference. Remember that this is actually 2. Then this bar here corresponds to 2 students. So the error bar, the Poisson error bar, brings it up to 3, which would be like 20%. So it's pretty much comparable. So we need to understand there's some parameter in the program that we need to analyze in what way we can help, because we want to tend to the three partner countries. And we want to make sure that students from the 3 countries benefit. And then what's the future? To finish the presentation, the future is that we're working on an ING science vision study. And this has started with a science vision document prepared by the Science Advisory Committee. Al mentioned the Dutch representatives in the Science Advisory Committee, because they're closer to you and you can then relate to them. Samaya Nisanke, Alex de Kotter, and Søren Larsen. So talk to them. We will very soon make public a summary of the science vision document that has been presented to the observatory now. This consists of a science vision to 2035. And contains elements such as upgrades to WEAV, both in the instrument, perhaps the type of detectors, the regard speed, regard noise, and also the kind of a scheduling, which any massive survey, spectroscopic survey, starts with very rigid, very well-defined scheduling reasons to make sure that things do happen, but then after things are running smoothly, then flexible scheduling allows to start tending to perhaps the time domain programs, understanding in what way targets of opportunity can be put into the program. Of course, that's it's not something that we want to accept in the first years, but that could make it easily, we understand, towards the future. And we're also thinking big for future projects also. It's not just upgrading WEAV, but what other instruments and perhaps what other telescopes? What do the community need 10 years from now at La Palma? In what ways would maximally benefit the development of the astrophysics in the Netherlands, the UK, and Spain? And we will do our best to push the most ambitious ideas, because this is what we're here for. You'll hear about it. We'll organize public sessions. We'll discuss things. I hope to visit the universities, the Dutch universities, once COVID restrictions are slightly lifted up. And so there's going to be talk about the future, because that's what we need to do now. We need to start the WEAV surveys, and we need to wait for HARPS 3, but we need to start thinking big for the future. And that's it. Thanks very much.
Thanks very much, Mark, for a very stimulating talk, and also mentioning the opportunities for the Dutch students, which I trust they will understand. Congrats to the WEAV team and the HARPS 3 team and your team. I believe that the future for the ING looks pretty good. There is time for one very pressing question. Just speak up who asks a question for Mark Balsijs. Well, I hear nothing, so thanks again, Mark.
Thanks to you.
And the
I'll stop sharing.
There is a discussion on the chat going on with Scott Traeger, so people who have questions regarding WEAV, they can talk to Scott Traeger. Marika apparently is ready. Marika, are you there?
I had to unmute myself, sorry for that.
Okay, we are a little bit ahead of time. Shall we do a 5-minute break after Marika's talk? Marika, you go ahead.
Okay, thank you, Peter. I'm going to talk to you about NOVA outreach and how you can get part of that. The organizers advised us to start with our take-home messages. So here we go. Contact us for educational projects, contact us for your press communication. But first, I will tell you more about who we are and what we do. So this is us, the NOVA Information Center. We are housed at the University of Amsterdam with 4 people. And what we do is communicate astronomy with and engage with press and media, schools and teachers, and the general public. My colleagues are Joanne Holt, David Redeker, and Joris Hansen. So here are the 3 main target groups. It's not all, but the main target groups: press and media, school children, and the general public. What we do with press and media, we write 80 press releases a year for NOVA, and also the EASL press releases we translate. And those are national and international press releases. We do media pitches, and we organize hundreds of media appearances per year on TV, radio, and in print, magazines and newspapers. We also organize and help with press conferences, and we organize press visits. The last visit to one of the NOVA labs was on Weave. So the previous speaker showed us a lot what happened since then, because this visit was, I think, in February 2020, just before the Corona broke out. And we had a group of journalists visiting the NOVA Optical Infrared Lab just before Weave, the spectrometer, left the building and was shipped to La Palma. So we're looking forward to the next press visit to La Palma with a couple of journalists and TV crews. We also organize since the Corona year online press talks with scientists, and that works very well because also the journalists are now used to use Zoom in their communication. An example of this is the Gaia early third data release end of last year. Ahead of all the embargoed materials, we organized this press talk with Anthony Brown, and that worked very well because we gave the journalists enough time to prepare their items and their stories. What we also do is media training for astronomers at all levels. Not this year, but we'll start it up again after the pandemic. We have a public website for the general public with news and press releases and agenda, tips for the night sky, and also NOVA information, background information on instruments and telescopes. And there's also an overview of our education materials and the public observatories. On social media, we are very active. It helps in distributing your news and your press releases. It's amplifying, and we reach a bigger audience in that way. And we also get very much questions from journalists on Twitter. This is an overview of some of our educational materials and projects. You can find more information on the website astronomy.nl. And I will highlight a couple of them. First, the Mobile Planetarium project in the Netherlands. There are 3 domes. 2 of them, the NOVA and the Leiden dome, are run by us. And Groningen has also a dome, and that's run by Marlies van der Wijgaard. And since 2010, we've reached over 300,000 school children. And it's 20% primary schools, 80% secondary schools, and that's about 15% of the annual cohort. We also appear at festivals, film festivals, science festivals, etc. But during the pandemic, things had to be changed because we couldn't go with a tent with fits for 30 children to the schools. So my colleague Joanna Holt quickly turned to domeless, from dome to desk. She designed a flat screen, and for secondary schools, we offered online-only planetarium shows and lessons. Bookings dropped, of course, to 1/3, I think, but they're getting up again. And there was a clear shift from secondary to primary schools. In my previous slide, I told you that we that it's 80%, 20%, and now it's just the other way around. But we have an opening plan that's aligned with the national opening plan, and we hope to be back to normal operations after the summer. On the 10th of June, there's a partial solar eclipse in the Netherlands, and on that day, the dome will be operational again for the first time at the primary school during this eclipse. And we also bring eclipse glasses for the children, and we'll look with them to the solar eclipse at the schoolyard. The planetarium project is also going abroad. Our former colleague Jaap Vreeling has moved to Sint Eustatius, and he's now unrolling there in the Caribbean dome project. On this picture, you see the blue outside dome, and he could buy that with support from the Van Dishoek de Zeeuw Fund. There's also a Rockbout Nova project in Namibia. That's part of the AMT Social Impact Plan, and with support from the IAU Office for Astronomy Outreach. These are two examples of our educational materials. The first one is an astronomy chapter in the physics textbooks. The curriculum in the Netherlands was revised in 2014, or no, before that. Peter Bartel was part of the commission who organized that, and after that we took over, and with a couple of astronomers we wrote the astronomy chapters for these school books. Another example is this build it yourself spectroscope with the high quality grading, and that's a success as well. It's still available in the web shop of an educational publisher, and we have distributed many since 2011. Features of our outreach are that we focus on high impact projects. We work together with strategic partners, and we have excellent networks within media, but also in the fields of education. We create room to experiment with new technologies. Production levels are high to achieve an ongoing presence in the media, and we reach a large audience with this approach. But we are, of course, not the only one in the Netherlands and within NOVA that do very important things for the public and for schools. Here are some examples. The Universe Awareness Space EU project by the group of Pedro Russo in Leiden. The Altair project by Sierra Markov in Amsterdam. Of course, the Dark Sky activities in Groningen, conducted by Marlies van der Wijgaard. And the Open Day Stargazing Nights, public talks, etc. We have some upcoming new projects. One of them is the IMC Weekend School, aimed at underprivileged children. There are, since many years, existing contacts for talks and planetarium shows, but Frans Nick, Leiden, and Joanna Holt, NOVA, are now trying to turn this in a more structural collaboration, because they reach completely different children and schools than we reach with our more conventional outreach and education. A second new project is the Data to Dome project Stargazing Live. Last year, we had a large grant within the NWA, and now we are with Radboud setting up a new planetarium project with a show, a film, lessons and educational material, and even a observer program. What's getting more important is impact measurement and evaluation, also in relation to the science communication funding. Groups in Leiden and Utrecht are working on toolkits for impact measurements. And we are setting up structural surveys before, during, and after educational projects. So it's now this, what we want to do is share the thrill of discovery, but in combination also with long-term effects. So here is in summary what we do and what we are aiming at. You can read it yourself. And here we are back again at our take-home message, because we need you with what we do. So if you have a good idea for a press release, for something else in communication, or for example, for the new round of the NVA science communication funding that is now available. So if you need a partner, if you have a good idea for whatever in communication, please contact us at nova@astronomy.nl. Thank you.
Thank you very much, Marieke. It was a nice overview of all the impressive education and outreach efforts that we are all together carrying out. It was good to see that you could also adapt the planetarium program to flat screen last year. There's time for one question to Marieke, but otherwise you can always reach her via email. Anyone? No, then I propose that we have a 5-minute break just to get some coffee or do something else, and we reconvene at 3:48 for the contribution by Marlies van der Wijgaard on the dark sky efforts in the north of the Netherlands. Thank you. 5-minute break. All right, welcome back, everyone. Can I ask Marlies van der Weijgaard to update us on the efforts related to the dark sky in the north of the Netherlands? Marlies, are you there?
Yes, thank you, Peter. And good to see you all. And indeed, I will tell you more about our efforts in the north of the Netherlands on the topic of dark skies. And for that, let me first share my screen. Can you all see my screen? Okay, so the program is called Donkerte van de Wadden, or in English, Dark Skies of the Wadden. And with this program, we aim to cover the north of the Netherlands, the Wadden area, with all kinds of activities related to darkness and awareness of the beauty of the night and the importance of darkness. And to get to our main goal, yes. So our main goal is, first of all, to make the natural dark skies an attraction for visitors to the Wadden Sea coast. So to make it really a quality that they will appreciate, and something that becomes well known as the quality of the. I try to move something, but it doesn't work. Okay. And to offer visitors a year-round experience that matches the Wadden Sea World Heritage status. So to offer activities during the whole year, during all seasons that are related to darkness, to offer visitors a way to experience darkness. And also, we aim to preserve and enhance the darkness by making people more aware of the importance, and by also measuring and monitoring darkness, for example, with our measuring node network. This is a program of many organizations together. We work together with, so the University of Groningen works together with the Nature and Environment Federations of Groningen, Noord-Holland and Friesland, with de Waddenvereniging, Staatsbosbeheer, State Forestry en Natuurmonumenten. And it is funded by the Waddenfonds, the 3 provinces and of Groningen, Noord-Holland and Friesland, and the Prins Bernhard Cultuurfonds. So it is a cooperation of many organizations, and this came to be by throughout the years, making more and more connections in this topic, and many people were already on themselves working on this topic, and we came together through the Waddenfonds and through the provinces to work together in this larger program. So if we look at the Wadden area of the Netherlands, then here we have a map going from the north of Noord-Holland to Friesland and Groningen, covering, of course, also the islands. And the program aims to deploy activities throughout this whole region. To give you an impression, here is a map of locations of the Donkerte van de Wadden program, where we build new activities for people to visit, or we organize events, and this will be developed more and more throughout the coming years. You see on the bottom right also an inset, a zoom in on the Lauwersmeer area. This is where we are now building an observatory. The University of Groningen, together with State Forestry, built this near the activity center of Lauwersoog. And there, surrounding the activity center and in the dark sky park Lauwersmeer, we will be organizing many events for visitors about dark skies. So the program is mainly divided in 2 types of projects. It is a combination of all kinds of projects, all driven by organizations within the program. And some of those projects are aimed at experiences, so to organize events or to build musea, make locations where people can go to, or about knowledge of dark skies. For example, our measuring node network, and informing people about dark skies. So why is this important? What can you do yourself? And these two main streams is what the project is focused on. Here you see an overview of the projects that aim to let people experience dark skies. Throughout the year, we will organize the Nacht van het Wat, which is a connection to Nacht van de Nacht, already a well-known event in the Netherlands every year in October. With the Nacht van de Nacht, throughout the Netherlands, people can go to observatory and locations to experience dark skies, and people are encouraged to turn off the lights. With the Nacht van het Wat, we focus this on the Wadden area, and 4 times per year we'll organize events for dark skies. Wat een Nachtleven is a project that will build night gardens, so people can go to a night garden and experience the nightlife, both plants and animals, and it's also aimed to preserve and protect those flora and fauna. The Dark Sky Park Lauwersmeer is what the University of Groningen is working on together with Staatsbosbeheer, and many activities are deployed there. It's focused around the activity center of Lauwersoog, where we are also building a new observatory, and we will expand those activities, for example, with night walks, stargazing evenings, photographer classes for night photography, and this will be throughout the year. And also we'll be building a new outdoor planetarium there to tell people about the night sky. And this is a cooperation of both astronomy and biology and science communication within the university. Also, going outwards from the Dark Sky Park Lauwersmeer will be the mobile planetarium and a mobile science truck, with which will travel through the Wadden area with a special program for dark sky activities. On Schiermonnikoog, one of the islands, in the duinen, there we will create an experience for visitors to go there and with a guide go through the area to experience beautiful dark skies. On Terschelling, near the Dark Sky Park, the Bosplaat, we will be building a night location where people can go to with an exposition and with telescopes and a map about how to explore the dark sky, the night sky. Also in the north of Holland, in the Gelderse Vallei, we are building more experiences on darkness surrounding a tower where people can look over the landscape. And in Wieringen, near the Jan Lont Museum, the exposition is now being built about dark skies, and that's actually going to open in June. And here I just show our observatory, which is almost ready. We are now finishing this, and we just had first light with the observatory. So this is in Lauwersmeer, and this will be a main part of the activities for visitors as well. Also, we aim to tell people more about dark skies by knowing more about it. So why is this important? What is darkness and how dark is it? So the university has built a sensor network and is developing this further, where the darkness is measured, and we also connect with citizen scientists to work on this network. For example, last winter, people could count the stars in the Orion constellation, and this is a measurement for darkness, and this will be continued throughout the years. Also, we aim to train people, so entrepreneurs, volunteers, people who would like to tell their guests more about darkness. So, for example, if you have a hotel and people are coming to your hotel, you would like to tell about what can you do in the area, and why is this an important quality of the Wadden area. And for companies, we will develop more products to be able to offer this to their guests as well. To give all this information to visitors, we are working on promotion materials, communication materials, like a night almanac, which will be a small booklet containing everything about the locations for dark skies in the north of the Netherlands. And we are working on a website which has just been launched last week. So you can go to www.donkertevandewadden.nl, where you can find an overview of our projects, both the experience projects and the knowledge projects. And you can also find the link to the social media there. And just to share a first result of the sensor network that we are building. So on the left, you see an overview of where the sensor nodes to measure darkness are located throughout the north of the Netherlands. There are about 30 of them, also a few actually in the other parts of the country. And on the right, you see a graph of one of the students that is working on the data, which is being collected since October 2019. And here you see a comparison or a measurement of the darkness, especially in April and March, which is compared to a baseline darkness given all the data of the months before. And what is interesting is that you can see that in these particular months, it seems to be slightly less, slightly darker. And this is the period that the corona situation, the corona lockdown started. So it might be that there's a connection between these two events. This is something that we are working on now. So to get back to our take-home message, so we aim to make the natural dark skies an attraction and to show that this is a very important quality of the Wadden Sea and something that is treasured and that we want to protect. And also to be an inspiration to the rest of the Netherlands, the rest of the world, to protect the dark skies. Do you have any questions?
We can accommodate one question. Well, if not, then let me thank you, Marlies. This is all very impressive and good to see that you're collaborating with these nature and environment clubs. Nice cross-fertilization. I'd like to thank all the speakers for their well-prepared talks on various aspects of hardcore and softcore astronomy. And I propose that we take now a 1-minute break before we start the business meeting of the Royal Netherlands Astronomical Society. Thank you, and we'll be back in a minute. Yeah, Frits?
Peter, didn't we have an announcement or something that we replaced the break with from Samaya?
Yes, you are right. Samaya, sorry.
No worries at all. I'm fine. I mean, I feel bad about taking people's time.
Yeah, I shouldn't have done the break earlier, but you have the floor.
Okay, thank you very much. Okay, I'm going to try and share my slides. Do you see my slides?
Yes.
Okay, perfect. So my name is Samaya Nisanki, and I'm talking on behalf of the Dutch Equity, Inclusion and Diversity Committee. This is a new committee, and it was officially established last April 2020. Details and what I'll be discussing in the next few minutes can be found on our website, which is located here. And so when we formed this committee, we wanted to ask ourselves, how can we best support scientists in the Dutch community, astronomers, and more broadly, how can we increase diversity and representation in the field? And our aim was really that the Dutch astronomy community is forward-looking in building a more inclusive, diverse, equitable, and accessible community to welcome all our members, to make sure that everyone has a voice at the table and to achieve scientific excellence. And so it became very apparent early on, and one of the reasons why I'm delighted to be here to give this talk is the necessity of engaging and supporting early career scientists and those particularly in underrepresented groups, and a realization in our community that society is ever changing and that astronomy itself is undergoing a transformation. We're becoming more global and moving towards larger projects and collaborations, and therefore this discussion needs to be all inclusive. So this umbrella national committee comprises 16 members from the 7 institutes that actually work on astronomy in the Netherlands, Astron, Esron, Jive, and the 4 university institutes. Each institute has 2 representatives that are either chairing or heavily involved in local equity and inclusion and diversity efforts. And this is allowing us to learn from each other in terms of programs and efforts, and give each other feedback on things that are working in our individual institutes. I myself am the independent chair at the moment, and we have an observer to the Dutch Astronomy Board through Michael Wise, who is the director of Esron. And so the names you can see listed here, they're also available on the website. And what have we done since we formed last April 2020? Well, we've developed terms of reference as well as a code of conduct for the entire Dutch astronomy. These are available on the website. We've had monthly meetings ourselves to organize ourselves and to discuss the best way forward. The local institutes have all held informal EID forums, equity, inclusion, diversity forums for early career scientists. We've formed statements against racism and inequity on behalf of the Dutch Astronomy Board, in particular engaging ourselves to direct action to address some of these inequities. We've developed a pilot program spearheaded by Jake Noel-Straw on creating your place in astronomy for PhDs and postdocs that's been running for the last 6 months. And we've also all recently undergone training for all our members to act as confidants or mediators or as low threshold access points to provide advice for members, in particular, if you want to discuss or have advice from people outside your own institute. And we are now actually beginning to roll out workshops that have been designed by ECHO. This is a Dutch NGO Center of Diversity Expertise. I've provided the link there. And in addition, we have also instigated a monthly equity, inclusion, diversity webinar series. And so we've had, and these have been accessible via Zoom as well as live stream on YouTube. So we've had speakers Jake Noel-Straw, Christina Ricci, who was the chair of the AAS Committee for the Status of Women in Astronomy, Jake Nordhaus from RIT, Nicholas Baum from Portsmouth, Jocelyn Bell-Burnell from Oxford University, and this month or next month, we'll be having Sanjana Panchagunula, who will be giving us her thoughts and perspectives as an early career scientist from Leiden University. And just to mention that some of our webinars have been approaching sort of 150 or so views on YouTube. So we're very delighted to see that people are watching and engaging in the efforts. And so finally, I'd really like to end with the point that we are a committee here for you. Please do not hesitate to contact us. As I've mentioned, our names can be found on our website, which is listed here. We really welcome feedback, thoughts, action items that you think we should be doing, criticism. We're very self-critical as a committee, which I think is necessary, and we absolutely cannot do this work alone. So in particular to the early career scientists, please do reach out to us. You can also write to us and contact us as a group in the below email. So I think I'll end there. Thank you.
Thank you very much, Samaya, and compliments to you and your team for very important efforts.
Thank you. I'm trying to see how I can mute myself. Sorry, thank you.
So then, thanks again, and we'll move on to the business meeting of the Royal Netherlands Astronomical Society.
There was one final question I got from Alexander. Are people willing to take a conference photo in this final moment? Like if everyone just opens their camera and then we take a screenshot of the Zoom room?
Sure.
I see lots of people appearing, so I guess it's a yes.
So Alexander will make the picture?
I'll take a screenshot.
Yeah.
Alexander was the one who proposed it.
Lovely.
I'll give everyone a minute.
Well, then we have a nice break before the business meeting.
Oh, still some people popping up. All right, I will start screenshotting now. So
Yes.
page 1 and page 2. Yes. Well done, people.
Good.
Well done, people.
Thank you very much.
So we'll be moving on now to the business meeting, the annual business meeting of the Royal Netherlands Astronomical Society. So the members of the society have received materials for this meeting, the invitation and the supplementary materials. So I'll give you a minute to dig those up, and then I'll start the meeting.
Okay. That's good.
So it's good to see there are still 49 participants. Great. This is the 2021 business meeting of the Royal Netherlands Astronomical Society. I'd like to open it. The Netherlands Astronomical Society, as you know, was founded in 1918. So we celebrated our centenary just a couple of years ago. We obtained the royal status. We are proud of that, but we must think about our next century. So that will be a main part of the agenda today. Can we all live with that agenda? Please shout up if you have points. So agenda point 1 was the opening and the adoption of the agenda, which I've just done. Concerning announcements of the board, this is an important year, as I just said. We have to think about our future. And you see that future of the society is actually a point on the agenda, point number 7. So we will get back to that. I'm now requesting a little moment of silence for 2 members who passed away last year. The first one is Huug van Woerden. The other one is Kees van Schoneveld. Let's just think a little bit.
May I interrupt here?
Yes, please.
Vergeet Jet Katzert niet.
No, we already did that last year, Jan.
Okay.
Thank you very much.
Peter, may I add here something about Huug? This is the first NAC ever that Huug is not attending. This is Rein Warmels told me this. The first NAC was 1941.
Yes.
And he was there at age 15. This is the first NAC he's not attending.
I'm sure you'll write that down for the minutes, right? Interesting. We have pictures, of course, of the first NAC in 1941, in which indeed, Huug shows up. Now, the minutes of the business meeting of last year, that's a little bit of a tough story. That meeting was recorded, but the recording got lost So we had to go back to our memories, and that went well. So that is what Reinier wrote up. But it turned out that this morning I retrieved my notes of that meeting. They were in a big stack of papers. So I could add quite a number of points to the minutes of the business meeting, an electronic business meeting of last year. So what I will be proposing is that Reinier and I edit the minutes again and that we distribute it again. So one of the points was there that we had a moment of silence for Jet Kathert, for instance. And we talked about the website, we talked about the royal status that was renewed. And I also mentioned the fact that our treasurer, Jan Lup, expressed a disappointment that a successor for him had still not been found. And we also mentioned that we were going to think about the future of our society, as we are not attracting new members from the young generation anymore, and that is worrisome. So my proposal is that Reinier and I rewrite or just add on a little bit to the minutes that you have in your possession, and that you will receive the update by email, and then we'll give you a week just in case you want to add or object or have comments. Is that agreeable? Thank you. The annual report of the secretary. Reinier, you have the floor. You're muted. You're muted.
So the annual report is with you.
Yeah.
Let's see. I will go over it a bit. Not very much happened. We had plans to have a teacher day that didn't work because of COVID. In fact, all activities apart from this NAC were suspended, except that we participated in the NAC at the EAS. We later decided for this year that this was okay, but not for 2 years, because you completely lose your visibility, and also people that from the Dutch community have a better chance to promote, to show off their science if you have a separate NAC. So this is what was done this year. Let's see. Yeah, so we have several problems, severe problems, in fact, with the website. This was, in fact, last year the message was totally different, because then it was almost there. This was actually a student in Groningen who got completely deranged because of COVID and was unable to function anymore. And then we at some point then decided that this is not going to go any farther. That was about 1.5 months ago. Now we're trying through other means to Amsterdam to get this website organized. So at the moment we don't have anything. That also impacts on administration and so on, because the website is linked to a database, and the old website is basically broken. So it's very difficult for people to update their information, and some people cannot even enter. So this is actually a very serious situation.
Yeah, I also take it very serious, and I promise you that it will be fixed by next year.
The other thing is that there's also some critical issues with both the treasurer and the secretary who like to be replaced. And this is something that we can say, yeah, but I mean, you can continue, but it's really, we really want to be replaced. And this is very difficult, and it's one of the reasons why we started thinking about the future, and this will come up in the program later. And I think that's it. That's all what I want to say here.
Yeah. Well, then we'll move on to the financial situation. So we have distributed materials giving the finances over the past year in comparison with previous years. And of course, we spent very little last year, and we cashed in quite a lot because our members are still happy paying their fees, which means that our grant capital is rising. So at the moment, we have 32,000 in the bank, which I think we should spend wisely, and I will make some proposals on spending it wisely in the next year. Jan, would you add some information on points here in the finances?
I have to unmute. I would like to add that the website is very important for me to be able to keep track of who pays and who doesn't pay.
The database is
last year I contacted many people who had disappeared, and I found them back, and I had sometimes very pleasant conversations over email with them. So and some of these people still were very willing to pay. Some people moved abroad, and as you all know, if you go abroad, any contribution is voluntary, that you don't have to pay. Once again, the only thing we spent money on was the two websites. That is the website for the NAC, for the KNA, of course, I should say, and the website for the Sterrenkunde Olympiade. And I had to pay, as you said, to return some contributions because people had who paid by direct debit. Some of them, the bank account didn't exist anymore, and I see a continuous erosion of our income. And again, I won't have new members as a treasurer because I'm worried, and especially as we want to, as we will hear, to have a more professional website. That means also professional money. So, and I have given also a small, say, a layout of what we should spend this year, and there will be a surplus, I hope. And again, I have estimated that we get about 4,500 euros in contributions, but that's not completely sure yet.
But the erosion is quite slow in the membership.
No, there are also people moving abroad.
Yeah.
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 And or even people who leave astronomy and for whatever reason they don't want to contribute anymore.
Yeah.
There's also new members coming. I mean, we have quite a few new members this year, but it's hard.
Tell me who they are.
Yes, it's hard because of the website to basically keep track and be able to charge them.
For example, I would like to have the form for the direct debit available on the website so they can send it to me. But now I have to approach people individually and send them a PDF, which they have to fill in and send back to me because I need the original. Okay, it all works, and as long as I'm the treasurer, I'll be the treasurer. But
yeah, but
it can't go on forever.
It is houtje touwtje, and I don't like it at all. So it is utterly important that we get a decent website and a database. And that will cost some money, and I'll be asking for that later today. So we have to ask the CAS committee, the evaluation committee.
Peter, may I ask a question about Jan's papers? And that's the balance na 2020.
Yeah.
That's a completely different format from all the other balances, because the first line, the eigen vermogen, is different from some that's below it. And all the other ones, the eigen vermogen is the total at the end.
Yeah, that's a typo. The eigen vermogen now should be 32,000.
Yes.
And the capital also.
Sorry, it's a cut and paste error.
Yeah, it doesn't matter what it is, but it's an error.
You're sharp.
The final version is with the secretary. I've over the weekend I've changed it, so it's after consultation with the CAS committee, who noted this.
Thanks, Wim. That answers your question, right?
It does.
Yeah. So our capital is 32,000, which is substantial. So we have to ask the evaluation committee if they can live with this financial report. Is there a representative of the committee who can say something?
Yes, of course. So Edwin and I verified the accounts, And we concluded that the full report is completely correct. There were indeed 2 minor mistakes made in copying information to the summary that you've received, but those have been corrected. So we can happily propose to absolve the treasurer and the board.
Okay, thank you.
Sigh. Okay, good.
So we have to ask new members for the evaluation committee, the CAS committee of next year. Anyone willing to sign up? It means that you will get to see the financial report of the treasurer a couple of weeks before the general business meeting, and you have to throw your light on it.
Don't be scared of the work. It took me about 20 minutes, so.
And you even found 2 mistakes, so you can do a thorough job in 20 minutes.
There you go.
Bedankt, Edwin.
Yeah.
I think that was a test. They put that in for us.
Yes.
Alexander Shulevsky raised his hand.
Wonderful.
One more volunteer. Ilse, thank you.
Okay, Reinier, we have 2 people. Ilse van Bemmel and Alexander Shulevsky. Wonderful. Now comes the proposed budget. Yeah, you already mentioned that, Jan. That's straightforward, right?
Yeah.
You want to add anything?
Well, I would like to say that we have leftovers from last year, so it's yeah. We'll have an income of about 4,500, and I don't know. The brochure, there's money being set aside that hasn't been used.
Yeah.
There was no NNV subsidy for to travel to La Palma, so it's all comes back from last year. So we're I don't know, and I still also don't know what in the second half of the year is going to happen if people travel again and things like that. So it's all PM, pro memory.
Yeah. Well, my proposal is that we reserve like 15,000 for the website and the database.
How much?
15,000.
Oh, so.
For the website and the database, and maybe even go to a professional desk to do administration, a small administration office to do a lot of the work that you are now doing on your free evenings.
Well, it's not that. I mean, it is a little bit of work every month. You have I look at the web at the bank account, and as long as the website works, I can tick on that people have paid. So it's that's. Yes. I don't know if you really want to have some outsider working on that.
I suspect that making a website will be a bit cheaper than that, Peter, even if we have it done professionally.
Yeah.
I think as far as the treasurer's work, I think we should have a look. It might be wise to reserve a bit of money. I think what would be a much more efficient thing is that if we simply switch to the situation where we require people to pay electronically. I know there is a small group of older members who dislike that, but basically I think most younger people who will, even most people my age actually don't mind, because it is the least fuss way of paying your bills.
I second that, Ralph. And also, like, for example, the Australian one automatically takes it out at the start of every year. We get an email 2 weeks before letting you know, and as long as your bank account details are up to date, it's just so much less overhead.
Yeah, we've always had a small group of senior members who felt that was not a good system. And they tend to be, if Jan can confirm me, also people who then typically forget to pay. So, and I think there will be very few of us who are in such a poor financial state that we will be bankrupted by a direct debit of 20 euros by the KNA. So
yeah. Well, again, I want to.
If you want to really, I mean, spend more on the website and support, then we can't go on with 10 euros for students and 20 euros for full members.
Well, I mean, I would say that depends a lot on how much the maintenance of the websites costs. I mean, getting the website up and running will cost some money, but I don't necessarily think that maintaining the website year on year will be that expensive.
Yeah, but there is also something about visibility of the the Royal Astronomical Dutch Society. So we'll be talking about prizes. We still give subsidies to meetings, and all these things are also important. And if these organizational matters take up all the income we have, I don't think that is a situation we would like to have.
But we want to seriously improve these things.
But I mean, I certainly think we need at the least to bring it up to the level where we don't atrophy anymore and basically simply don't get new members because we are unable to keep a good administration and an online presence that is consistent with modern standards.
Exactly.
If I can quickly interrupt, this will tie in a lot with the discussion that we'll have after my presentation in a few minutes.
Yes.
And I think it would be a very good idea for the board if they go over the recommendations and make a plan of action with an associated budget, so that it's clear what kind of costs we're talking about and what the impact is on the membership fee. Because it's a lot of what ifs and what could be's, but it's clear that something needs to change. And there are some good suggestions in which direction that can be done, but it's up to the board to decide what they want to do with that.
It's clear, at least to me, that it is substantial.
Yeah. May I please make a remark? I'm a member of several societies of the size of about this society. And in the past, many of these societies had an automated system for getting money from people. But most of these societies are moving away from them, are just sending out emails to people asking for their annual contribution, send them a reminder. That's quite easy to manage. And I think the system that we had, where people could indicate on the website, control their private details on the website, I think that was very complex. And that it may indeed be very expensive to set something up like that again. And I wonder whether it's really necessary, whether you should just, well, you need to have a very good website to give information to people, but having the website with a database behind it, which the members can maintain themselves, it may just be too heavy for a relatively small society like ours.
Thanks, Edwin. Yeah.
Leonid has his hand up. Peter, Leonid Govic has his hand up.
I hear nothing.
Leonid, are you muted maybe? You have your hand raised, but we can't hear you.
Can you hear me now?
Yes. Yes.
Good, thank you. In fact, I can switch my camera now, I think. Anyway, I don't feel that strongly about the difference between automatic payment and through bank transfer and manual. However, I would like to make a point that over many years of my membership in NAC, it was typical that the reminder that there is NAC and I'm a member comes once a year in the form of request to pay fee, which was fine. I mean, that's that at least that reminder. And switching to totally automatic would be okay if we undertake to maintain some more active visibility for members. If it happens, then of course, automatic transfer from our bank accounts would not bankrupt anybody of us. That's fine.
Yeah. Before Ilse starts to really smile very loudly, I think I would make the comment on her behalf that it would be a good idea to hear her presentation first.
All right.
Yeah, you're
I can almost skip entirely.
entirely correct, Leonid.
No, please. It would be good if you could.
So we move on to agenda point number 7, and the word is to Ilse van Bemmel on behalf of the Evaluation Committee.
Yeah, I'll try to share my screen so you can see the presentation. If I'm not mistaken, you should be seeing now, when it's fully loaded, the presentation.
Yes.
Perfect. Yes.
So thanks for the opportunity here to talk on behalf of a group of people about the future of the RNAS. And as you might notice already, I picked the acronym RNAS, and that's for a reason. So this is on behalf of this group of NAC members, RNAS members, sorry, now I go myself. We were asked by the boards to talk, to brainstorm and discuss the future of the society. And as you can see by the names, it's a very diverse group, both in the stages of career from all the institutes in the Netherlands and Belgium, and also gender-wise well distributed. So that's a very good thing if you want to make changes. And my compliments to the board for taking this action and actually getting this group together, because I realized there is serious problems that need to be addressed. And this is a very good way to handle that. So the questions we were given from the board are these 5. And if you want to read in more detail what we discussed about that, you can look at the appendix in the invitation. I'll just go over the main aspects of this. So what we already discussed, why are younger people not joining, is a major issue. What should the role of the RNAS actually be? Which activities could be abandoned or stimulated instead? And any further suggestions that we could come up with were welcome. We started the brainstorm discussion on Zoom with the majority of the members in the group, and we quickly noted we had no idea what the official acronym of the society is. And we've already noticed in the meeting today as well, people use NAC, the old acronym, people use KNR, the Dutch version, there's RNAS. And as you can read here, there's several aspects that made it clear that the visibility of the RNAS is not well. There is no social media presence. We discussed the website problems. The board members are all senior white Dutch men. And in a way, the RNAS and also the meeting, the annual astronomer meeting, are outgrowing itself due to a severe lack of community building. People do not feel represented, so they will not join the society. They will not be eager to be active. And I was talking to a colleague just this week about this discussion that was coming up, and he mentioned, I don't even know if I'm a member. How can I check? So it's clear that some interface, some changes are welcome. And I think we've already heard that everybody agrees on this. So then we went on, instead of looking at what is not working, what is the unique aspect of the RNAS? And there's definitely an aspect that is very unique. It's a community of individual astronomers in both Belgium and the Netherlands. So it's crossing institute boundaries, it's crossing borders, it's crossing scientific disciplines. And as Jan mentioned during our discussion with the board, it connects active research astronomers with people who are an astronomer but no longer active in astronomy. And this allows you to represent astronomers and non-active astronomers per subgroup in many, many different intersections. You can start to make smaller groups, which then feel connected and build up from there towards the entire society. So what actually needs to be done is a reconstruction of the identity. What is the RNAS? And the themes that we came up with are roughly these 4 that need to be worked on. The visibility of the society is really crucial. A non-working website, having a form that is not working for membership application, that really can't be the way to operate, and you are well aware. Communications about the RNAS, but also with the membership, are essential for the next point, also for the community building, and that can be in different aspects. And most of all, also the diversity of the society can be significantly improved. So to make this more concrete, I've summarized this in 4 main recommendations, and you can read in the document. There's a lot of detail in this, and all these things tied together. You cannot do one thing without the other. But we need to be setting priorities, because there's also a financial aspect to this, of course. So one of the easiest things to do, to change, is actually the board representation. So we recommend that there is a board position for a PhD student, an early career scientist at a postdoc level, and a tenure track junior staff member, at least secured. And that may be meaning that the representation of each institute is no longer as easy as it used to be in the past. But that could be replaced by having RNAS representatives in each institute. So people who advertise and advocate on the behalf of the society, but are not necessarily tied to the board activities. The second aspect, and I think this is one of the most important ones, is the community building. Online presence and visibility is terribly important nowadays. If a young PhD starts their career in the Netherlands, half of them don't even know what RNAS is by the second year of their PhD because they can't find the information in the channels where they are looking for it. It was suggested to have a dedicated Slack or Discord channel. Any of these services is fine. Accessible membership, so that if you come to the Netherlands, you can figure out who else is working in my field, where are they based, how can I contact them? And we discussed events for specific career stages, like the NOVA school combines all the PhDs once a year here in Dwingelo. Similar events or one-day events could be organized for postdocs or junior tenure track people to make them connect to others and exchange their experiences. And one of the strong points of the RNAS is that this can also be done between astronomers and non-astronomers. So people considering to leave the field or to re-enter the field can exchange experience on how to approach this. And I think an important aspect of this is also that the annual meeting is really structured now across the NOVA working groups, and this makes it easier for people to just disappear if there's a science topic that's not in their field. If they're not part of the network, they will just not attend. And this counteracts all the community building that you could do. So rethinking the format of the annual meeting is also an important aspect. So the last two recommendations, was already slightly mentioned, the prizes that we've discussed. Establishing prizes has been proven to be a very strong way to attract people to the membership and also keep them and encourage them to be visible inside the membership. So there are already some prizes. We need to probably consolidate with what exists, look at the financial aspects of this, but things like an annual best PhD or a best paper from an early career scientist or at any other level of the career, things like that could definitely help. And finally, last but not least, a warm welcome for new members. By default, everyone who joins a Dutch or Belgian astronomical institute should get a welcome message from the RNAS. This is us, this is what we do, this is what we can represent you for, and this is how you get the membership. Just a simple one-click form where you can fill out your details and be a member. And that also includes, again, accessible websites, social media presence, things like that. And something I've not mentioned yet, I think it's also very important that this communications with the members is followed up. So now we hear from the RNAS typically maybe once or twice a year when there is a meeting coming. Outside of that period, it's relatively quiet. So there's no incentive to become involved or think about aspects of the society. And what I've also noticed, a lot of the information still is in Dutch, with the junior population in the Netherlands being predominantly non-Dutch. This makes it really hard for people to get involved as well. So these are some things to think about. And I think I give the floor back now to Peter for the chair and see what the next steps are going to be. Thank you.
Well, as we already said, we were extremely grateful for all these very wise recommendations. Some of them do not come as new. We had to realize them themselves, but there are also some real original ones among those. We have to balance, though, the ambition and the realism. So I think it's up now to the board to make a prioritized list of what we shall be doing to improve things. The key is the community building, and I think I realize that, but a lot is missing. So who would like to comment? Who has not seen this report before?
I've seen it, but I would like to comment.
Go ahead.
In that, I think one of the things we had in there, especially, is the point about how even in these last 5 days, the meeting has been arranged is by those, this is Nova 1, this is Nova 2, this is Nova 3. This is not the community of astronomers in the Netherlands. This is then organized by how Nova decided to do it, which, though I think we're all engaged now in somewhere or another, it's not making that be this separate astronomer community thing that should be the community of astronomers in the Netherlands, not tied to which of these other things you are at work.
Well, I should comment, of course, that this was really an ad hoc Netherlands Astronomers Conference, Jake. So we tried to make the first day sort of general,
exactly.
reviews for everyone. The last day sort of accessible to everyone, but we then have the networks think on the program of the days 2, 3, and 4. So it was born a little bit from necessity. In true live Netherlands Astronomers Conference, there's a lot more community building.
For sure. I just think it shows, like, be careful about where that mentality is what I'm saying from the group we have, just that way.
Yeah.
Yeah, and so to add to that, we've also noticed in the later, say the last 5 to 10 years, the Dutch meeting is becoming really, really large. So it becomes much harder to connect to people outside of your own field or outside of your own circle with who you already interact, because it's simply easier to talk to somebody that you know. And if I think back towards my first astronomer conferences about 20 years ago, that was very different. And this could be something to, if you restructure the meeting across different intersections, or maybe make it smaller or longer, it might be easier to accommodate this.
Yeah, maybe I can also add something here. I mean, the fact that we are getting bigger and more diverse might also lead to other things, that you might make the NAC more like a NUM meeting in the UK, or even in the direction of the AES. So very, very much many parallel sessions, so very large, meeting other people. And you could, during the year, you could have several RNAS sponsored other meetings. And I mean, realize also that the RNAS is not just professional astronomers. Yeah.
Other comments?
Yeah, I'm really very grateful for the ad hoc committee and its recommendations. I think the proper community building is really our first assignment. I mean, once the community interacts with itself more again, then I think there will be a much better platform for suggestions for improvements, different meetings, other ways of doing things to emerge, and for more voices to be heard in helping us connect with everyone. But I think indeed also a very interesting and important issue is that what things do we still organize that make the connection between those of us who see each other every day, the astronomers who work in the various institutes, and those of us who no longer work in astronomy, and therefore for them the society is the only connection with this community still.
Well, for those, we had prepared this Teachers' Day end of September last year, and my hope is that we can do that annually to connect to everyone in the society.
But they're not only teachers, of course.
Peter Thijs de Grauw has something to say. Has raised his hand.
Thijs.
Yes, thank you. Thank you. I think it's a very interesting report. I fully agree with those statements. But what will now happen? Okay, is it just another report and it's going into just another drawer, or is there action going to be taken? I think you should establish a dedicated working group for implementation of these recommendations. I don't think you can rely on the board of the NAC to do that. Okay, you have to look for people who are willing to spend some time and energy in this. And so my recommendation is get such a working group together. Thank you.
Thanks, Thijs.
I mean, these ideas have been floated around, so I I think the board is fully in favor of this. It just has to happen. So I mean, please remind us, but not only remind us, let the community make sure that this happens if the board doesn't do it.
Yeah, the board fully expect to be fired if we don't execute most of this program in the coming year, which will of course present an interesting conundrum in terms of that it has been hard to find board members.
Yeah, maybe firing is not enough. Should be tortured.
Thanks, Thijs. I trust you to contribute to that in person.
Frank Pijpers?
If I might contribute as sort of a former astronomer, if I'm tasked with implementing some things as a project manager, I usually have to give deadlines by which I have to have done something. So perhaps your first deadline, you need to agree on when are you going to have this new website online. Sometime next year is not precise enough a deadline if I am in my project manager suit. So make clear arrangements by when are you going to do what. And try to get that done this year, indeed, but not as vague as, well, by the next NAC we'll have done something. Make a precise plan and get it done. And if you need to hire a company to build your website, I know that there's plenty of them. There's small student companies that do this for minimal fees, or large professional ones that charge you at least 10,000 euros just to find a logo for you. So anywhere in between that spectrum, you'll find something that is appropriate for building a website that'll do for keeping in touch with your members. So I would say that is the very first priority to get that done, so that you can keep your members on side and can open communication channels with your members.
Thanks, Frank. More comments?
If I can comment something, my suggestion would be, first of all, get a new board, a diverse board with new people who wants to do things and wants to give new momentum. And, like with this diverse board, you will be able to, collect better requirements for the website and really get new ideas of what this website will satisfy. If you have, let's say PhD students on the board, postdocs, they will tell you what they would like to see on this website. So yes, my first recommendation is, get the new board with all the diversity that we have been mentioning.
Can I ask, is this Aurora?
No, this is Nadia.
It's Nadia, okay, sorry, because I'm making notes.
Yeah. I can promise you that we will get new members on board. And totally new board is out of the question at this moment.
No, but 2 members basically need to be replaced. Renier mentioned that. So there is a unique opportunity for everyone who takes this very serious to step forward and become a member of the board.
Absolutely, yeah. And we've been trying to replace these people for 2 years now and have not been successful.
And I gave it Thijs and also with Ralph. I think the report is really has very many positive points that should really be taken seriously.
Exactly. So my proposal would be that the board comes with an action plan, including some deadlines, and distributes that action plan before the summer. What do my board members say?
I think that's absolutely a good idea. I think it's a bit of a catch-22 between recruiting new board members and making the job attractive enough that new people will want to step up.
Yeah.
But I think we are open to anyone who is volunteering as of now.
Absolutely.
I think with the report in hand, it might also help to engage people better. There is a direction where things are going, it's going to change, and people may be more motivated to join.
Yeah.
Any more comments on this? Point 7, the future of our society.
Steven?
Are there any thoughts on the size of the board? Because currently I think there are 3 official board members and then a few assessors.
The bylaws says minimal 5, if I remember correctly.
Yes, that's already an interesting point. So I think it could help if you invite new board members for them to be added to the board and let the people with experience in running the NAC also in there still for a while, so that the new people can maybe focus on getting the community more engaged in the beginning, rather than, for example, the administration. That also needs to be done in the coming year. So maybe you could go into more of a transformation stage where new people come in and add in their extra ideas rather than replacing the whole board at once.
I agree.
It may be more interesting for people who want to join.
And there's other people who can do administration.
Good point.
More points? So I got an email from Leo Burtje from Leiden. If our Royal Netherlands Astronomical Society would endorse the efforts of the Earth Day community. And we have asked Leo to say a few words on their behalf. Leo, the floor is yours.
Thank you, Peter. Hello, everyone. Let me try to share the screen. You should see a graph now.
About CO2 emissions.
Yeah, okay. So this is, I have 3 or 4 slides just, this should be relatively quick. So thanks for letting me speak about this here. As you are probably all very well aware, we are in this global crisis at the moment because politicians haven't heard or haven't been listening to scientists for several decades now. And so CO2 emissions should have been decreasing since the 1990s by a few percent. It would have been easily possible, but unfortunately they have been increasing all the time. And if you wonder, due to Corona, there has been a very, very minor dip, 9% in the second half of 2020. It was already over again. So we're still, unfortunately, more or less in this, at least not falling trajectory. And as you can see from these global carbon budget calculations, if we want to stay within somewhat safe boundaries for everything that we rely on as humans and as astronomers, then we need to start reducing emissions very, very quickly. And things are moving very fast these days. I mean, you have probably all seen the big news about Shell losing in court in The Hague yesterday. And then in another piece of news, the Australian National University just a couple of days earlier announced that they want to be carbon neutral by 2025, which is really, really soon. That's in 4 years, announced by their Nobel Prize winning deputy chair or vice chancellor, Brian Schmidt. So this has really become a core issue also of astronomers. And I just want to highlight briefly why we should care as astronomers. So this is, of course, a general global crisis, so everyone should care. But there's a couple of reasons why we specifically should care as astronomers. This is, unfortunately, a picture where there's many now of fires near observatories. So point 1 is it's in our self-interest to be aware of this crisis and apologies, and to act accordingly, because the crisis is here, whether we like it or not, and it's real, and it will become more severe in the coming years and more pressing politically to do something. In a couple of years, it will be much more expensive to burn fossil fuels, and at some point it will be phased out completely. But at the moment, we still really rely on fossil fuels for many things that we do. Someone once said telescopes run on diesel. It's fortunately not true for all telescopes, and also not true literally. Some run on gas, but most actually still run on fossil fuels, because it's hard, of course, to put, or it was hard at least to get sustainable green energy to these remote locations, at least for some facilities. And also, of course, we're flying around quite a bit, at least we used to before Corona. And so all in all, astronomy has a huge carbon footprint, actually larger than some other sciences. And so that's something that we need to address. The third point here is there is this very powerful slogan that the climate movement is using all the time. If you ever go to a climate rally, you see lots of posters saying there is no planet B. This is an astronomical statement, so that's really us. So in terms of outreach, what Marike said before, we should really use that opportunity and get in touch with people. Astronomers are very trusted people in the society. We have fantastic things to say, and we should make use of that opportunity and also use that, I would say, responsibility of our huge reach, and tell people that, look, it's the same kind of science. If you trust a black hole, and last but not least, we can actually do this without, we can actually do astronomy without ruining the world, so to say. There's plenty of opportunities now that go from online meetings, which of course aren't as nice. I agree, at least partly with this. It would be nicer to meet everyone in person and have a coffee. But there are some options to do this with much lower emissions. And there is green energy around now. So we just need to become part of this movement and really press for this. And so to summarize all this, I've been actually helped build up a movement called Astronomers for Planet Earth, which has by now more than 1,000 people all around the world. As one of the biggest actions so far, we have written an open letter that you can see on the website, which I haven't put in here now, but I can put it in the chat later. It's just astronomersforplanet.earth. .earth apparently is a top-level domain. Didn't know that before either. And in this letter, we very briefly at page 2 lay out what the crisis is and what needs to be done. And we name 3 specific goals that we would like astronomy institutions and societies to adopt, namely, name sustainability as a primary goal. So don't just pretend that we're living in vacuum, but we are part of this world and we need to take that into account. Put sustainable practices in place. So try to reduce our own emissions. And the third point, which is perhaps the most important one, communicate this. Talk about sustainability. Talk about why Earth is such a special place. You know, we heard before this fantastic talk about comparing different planets and carbon cycles on different planets. I mean, we have a lot to say about this, and we can combine this and put out this message and add to the growing momentum to overcome this crisis, which I believe, I'm quite hopeful that we can actually do this. I have one last slide that I'm just going to flash very briefly to show what this would mean. So if the Royal Netherlands Astronomical Society would endorse this letter as an institutional signee, then above here is a graph showing where the emissions are coming from. It depends a bit on, depends a lot on country and also a bit on what exactly you're doing. The 3 points that we could do, I mean, one is it would be a huge moral support. We have by now a small number of institutional supporters, including Leiden Observatory. And it would be quite good for us and an important support for this letter and for this whole movement if a valuable organization like us supports this letter. We can also conceive at some point, and I'm happy to help here, what are our own emissions as RNAS? Is it the annual meeting? Are there some other things that we can work on and make an effort to reduce these emissions? And then last but not least, and actually perhaps most importantly, talk about these things and make sure this becomes an important part of outreach talks. Thank you for listening.
Thank you very much, Leo. And as I told you already, the NAC board fully endorses your efforts and your responsibilities.
Thank you.
And let me know what we can do more for you.
Okay, we'll be in touch.
Are there questions to Leo?
Thijs still has his hand up.
Thijs?
Or maybe that was still from before and he forgot to take his hand down.
Can I ask something here? I mean, the IEU, the EAS are organizations that actively encourage this kind of reduction of emissions. Do you think that one of the future goals of the RNS could be to set up a sustainability committee or something like that in agreement with some other organizations? Would that be a future role of us? What do you think, Leo or other people?
I'm not sure if this is what is most important for the RNAS. I mean, there is already a sustainability committee by the Raad van der Astronomie, right? I see Stephen here. I see.
Yeah, I mean, I was just going to note that actually some green astronomy goals are going to be written into the strategic plan for Dutch astronomy for the coming decade. So in that sense, it has attention, but I think it still helps if an organization like ours, on behalf of all astronomers in the Netherlands, basically puts its weight behind a statement like that, right?
Yes. On the new website, of course.
Yeah.
Mm-hmm. More comments?
Joe has his hand up.
Yeah, I just wanted to support Leo's comments completely, but also this kind of goes to speaking, Ilse just didn't touch on it, that the NAC or KNA can be more of an advocacy group on behalf of all astronomers. And this hopefully comes with clearer communications, just in terms of like improvement for the organization. And so using Leo's initiative here, we could definitely, this is an example of how the NAC could be more of an advocacy group for all astronomers in the Netherlands, or at least the membership body.
Yeah.
Okay, I see that Rolf has to leave for another meeting.
Yeah, I'm so sorry, guys, but I fully support this.
I have reached agenda point 9. Any other business?
Jan-Luc has still his hand up, Peter. Maybe you don't see him.
I don't see him. No. Jan.
Yeah, I want to remind you that in the past we used to take our bicycles to go to the NAC and come by train.
Yeah.
Oh, this is green, I hope.
Yeah.
Yeah.
This meeting itself is not very green, I'm sorry.
Any other business?
Sven has his hand up.
Well, since we are organizing the next NAC in Flanders, we'll definitely try our best to do it in a place that is within reach of, let's say, a train station or tram or whatever, so that people, at least from the Netherlands and Flanders, don't have to whip out their cars to get there.
Can I ask you when the date? I thought the date is known, so maybe you can mention it.
I don't remember exactly the date. It's the half week before Ascension, at the end of May next year.
Yeah, May 2022.
23 to 25.
Yeah.
Okay. Yeah.
So that's Monday, Tuesday, Wednesday. Monday, Tuesday, Wednesday.
Okay, thanks for mentioning this, Sven. If there are no more comments, then I'd like to close the meeting and say you all stay healthy and hope to see you all then in person in Flanders in May 2022 at the next Netherlands Astronomy Conference, where we surely will have an algemene ledenvergadering.
Yes,
Thank
but
you
maybe
all.
before as well.
Yeah, and you will hear from us very soon from the board.
Yes.
Thank you all for your contributions.
Bye.
Bye-bye.
Bye.
Yeah.